Welcome everyone to this demo deep dive episode. So to the product managers and the developers, we're here to interact together essentially. So have a scan. If you know the drill, you know the drill. Just have a scan of the QR code in the corner and join us on this adventure. So today we're talking about agentic AI and one of the most overused terms right now, but we're here to go past the theory and actually show you how to interact with these real systems in a safe way, that is. And so we want to deep dive a little into how Red Hat does it as well. And I'm joined here with my co-host, fellow Red Hatter, fellow DJ, fellow Globetrotter, Cedric. Hi, Cedric. How's it going?
Thanks, Rohan. Yeah, man, it's a pleasure to be back on the show. We've switched spots here a little bit. If you've joined us on previous demo deep dives, which is fun. So Rohan, thank you for hosting, for producing the show. He's behind the scenes normally, making sure that the streaming works and that we have this content and these experiences ready for you guys to learn about open source technologies. But now we're going to switch the tables a little bit. I work as an advocate here at Red Hat, so I help people learn about what Red Hat technologies are with Linux and Kubernetes, and specifically AI today. We're going to be talking a little bit about agentic AI, specifically what is it and what you can benefit from as a developer, as an engineer, and with Red Hat AI. So excited to be on the show with you here.
Yeah, I mean, yeah, like you said, we started this adventure together, and it's an honor starting 2026 on this note. And so, yeah, we want to dive into these, these buzzwords, the agentic AI, LLM, MCP. And so before we jump into this demo, can you level set us? What problem are we actually trying to solve here? And before you get into that as well, just make sure everyone's scanning. So essentially, we're going to be doing an interactive demo. And so for you to join along, you can do the demo with us. So yeah, what problem are we actually trying to solve here?
Yeah, so I think that's a great question. And you kind of mentioned the QR codes. That this will bring you to the site that we're actually on here, where we're going to be taking a look at specifically one of these AI demos. So you can see there's a lot of different capabilities you can do with open source AI, and specifically with the Red Hat AI portfolio. And we're going to be talking about a little bit about agentic AI, and specifically the MCP servers that you can work with, that can kind of help you as an engineer, as a developer. And to kind of level set, yeah, so I guess this kind of brings us right into the demo that we're going to be taking a look at today with MCP servers. So MCP, agentic AI, these all kind of revolves around how LLMs can access data sources. So data sources is the Slack channels that we're in every day. It's the Jira tickets that we have to add information to. It's the spreadsheets that we add columns to. And a lot of this is data heavy work that we're all working in as individuals, as managers. And the thing is, the way Rohan does something is probably going to be a little bit different than the way I do something. And so, this is like a perfect situation for an LLM that might do things a little bit differently every time, but always have the same thought process and reasoning to be able to go in, kind of automate some of these tasks, extract huge amounts of data that would typically take one of us, hours to sort through, and extract these key details and actually make actions happen. So that's kind of the gist of what agentic AI is. It's been a big hype for 2025. I think 2026 is the year that you're actually going to see it in production. And we're going to show some examples of how MCP servers work, which is Model Context Protocol, here in a second.
Awesome. So I guess get right into it. And I guess we do start with maybe, defining LLMs and that early stages of why it was great and why also it has its limitations, yeah, cool. Okay, these systems are talking and all of that, but tell us more about, where we used to be and where we're heading.
Yeah, exactly. I mean, I think both of us and everyone who's joining us here today can kind of remember the first time that they interacted with like ChatGPT 3.5 or something like that in 2022, 2023, where you could ask a question And based on the model's training data, all of the tokens of information that it had scoured the internet and books on would give a response back and answer your question, right? So it was really cool to see this natural language or NLP capability. But the thing is, what if we had sources of data that we needed to collect from, right? Because the training data isn't going to help if you have private data, company specific data, data that's locked up in a spreadsheet, a PDF, anything like that. So you kind of went from basic interactions of LLMs to interacting with retrieval generation, so a retrieval augmentation. So let's say I have a PDF. How do I make sure that the LLM, which typically would just have access to the training data, could get information from a data source? So that was the big hype of RAG. So RAG was a way to call information from data sources and PDFs and spreadsheets. And the idea of agentic AI is going beyond just data sources of PDFs, but also services, REST APIs, um, different endpoints that we might be connected to that we want to retrieve information from. So if I say, hey, what's the weather today? The model isn't trained on this information, but it knows how to make a tool call in JSON. The tool call is then, say you have Claude Code or you have Cursor or one of these kind of MCP clients. Well, that client then uses a server to make that actual request from the LLM. So the LLM says, I want this information through JSON, sends that to a MCP server, which actually knows how to make the calls because it's just written in an actual deterministic code like Python or JavaScript or any type of client or server for MCP, and then get that information back. So I know that's a lot, but here's a good example of it. So an orchestration API, you could think of this as an MCP client, would pass that request along to the model. Model is trained to know to make a tool call. So when we go to an MCP server, which could be somewhere on the internet, we get that request back. It's parsed by the model, and then the model knows how to take that response back and give it to the user. So I know that's a lot, but it kind of
I
allows us
feel
access to enterprise systems and services and APIs beyond just this closed box system that we originally had.
No, it totally makes sense. I mean, here's the visual representation as well. So for maybe product managers or people who might not want to deep dive as much, we still have that visually. And so we can also see that, yes, early LLMs were great at answering questions, but they were blind to, like what you said, the real-time information, all those like like more private or other systems. And so, yeah, I think it coming together answers a lot of questions. So for everyone out there, for AI, let's say AI, agentic AI is like, I guess, LLMs plus tools plus orchestration. Could we say that?
Yes, LLM plus tools plus orchestration. You nailed it on the head. LLM to be the brain or the operating system. Tools as in like calculators and Gmail and Slack and Jira and etc. And then reasoning and kind of the ability to think and process and say that, hey, if I made a call to this API and I get this information back, is that information what the user wanted? So you add those three together. That's called the React type of pattern of reasoning and action, and that's what powers agentic AI in pretty much every capability that you can see today. So Gmail's, kind of Gemini assistant there, or Amazon shopping assistant. All of these different agentic applications that are already being deployed right now all use the same type of pattern. And this kind of brings us to how are they making these calls? So say, for example, we're wanting to check the status of a cluster that's on OpenShift. So typically as a sysadmin or as, kind of someone who's managing this cluster, I would need to go into this cluster, do a kubectl or go in the web console, get that information, parse through the logs, parse through the events, and then finally understand, hey, is this, is there an issue, a bug, something going on here? The idea is here we could put something into plain text. Hey, check the pod logs for my project on Kubernetes. Make that request with a model that might be running locally, so we're not sending private data to a third-party service. Using an MCP server, and we'll talk about how the MCP server runs locally or on a cluster here in a second. But being able to get this information back in plain text. And then let's say I want to check one of these logs here. So this Blackjack app, which probably is my application running, it will check the logs for me, and I can take that information, connect it with another tool. So, hey, I have a Slack notifier here, and I want to share this with my operations team. Well, it'll take what that information originally parsed with was and send that as a Slack message. So make a post request to the Slack API, and the MCP server is kind of the blueprint to make that call. So here we see after I made that request, it sends the information to the Slack environment that we have. So essentially, in just 2 or 3 different natural language queries that I had to a model that's running with MCP enabled or agentic AI capabilities, bam, we're able to do the task that would typically take me 20 minutes to an hour in just a few minutes. And that's kind of the realization of like, hey, agentic AI is going to change a lot of different workflows, right? It's going to make me a better engineer because instead of having to sit through and kind of parse all this lines of logs and different entries that I'm getting back from my OpenShift environment, I can use something like this MCP server to help me do that and make those calls that I would typically do myself.
Very cool. I mean, the tool calling, the agent isn't just guessing, you can see these real life systems being called, and thanks for the Slack example. We are a Slack company, so this gives me some ideas as to how I can maybe work on some of my projects like this. But yeah, so what would you say this would normally look like if the agent wasn't there?
Yeah, I mean, this is kind of, traditionally how sysadmins and ops teams have been going about this is, hey, there's an unhealthy deployment, or I have a health check set to constantly check and see if the application is running properly. Agentic AI is kind of not a replacement for that, but it's just a supplement to say, hey, think of like the on-call employee, the SRE, who's always having to sit there and respond proactively. That can be aided with agentic AI, where AI doesn't get tired and have to like process all this information and have cognitive load. It's just sitting there. It's proactive, especially with Ansible. What we see with agentic AI is just proactive operations responses to say deployments or automation that we might have in various different clouds. So if something happens, that event will then lead to some type of LLM, process that, and make the response needed to correct that action. So let's say if the database goes down or something like that, you can apply an action automatically. And so that kind of brings me to different types of MCP servers. So if you go to Model Context Protocol, this is Anthropic's kind of homepage on how the standard works. And it's just a standard. So it just outlines how, in an open source way, you can build these servers, which could run on your own machine with maybe a Python or a JavaScript application, or in a container on a cluster, for example. But it also shows you in the community a lot of different servers you can use. So one of those servers that we just saw is the Kubernetes MCP. So I'll come over here, and if you go to github.com/containers/Kubernetes MCP, you can see this one that we've been working on here at Red Hat that allows you to call Kubernetes and OpenShift environments to get information on pods, namespaces, projects, in a read-only version if you want to be safe and diligent, or you can also allow it to make these updates to your cluster as well, so to take action. So there's a lot of good places to start. Fortunately, this whole ecosystem for MCP is open source. So I can actually go in here to the application, and this one's written in Go in particular, and see how it works to make the calls to the application from our LLM as well, which is really cool.
Awesome. I feel like this gives you a little insight into how Cedric is involved in a lot of projects. And like we said, open source, it's great to have those contributions across, across so many communities, but also being able to implement this in your own enterprise. So we'll get to that as well with regards to, how we can go about it, like what makes, companies nervous. But first off, with the MCPs, kind of feels like it's a lot like Kubernetes, what they did for containers, but for AI tool access, right? And so what do you think? Like, how does MCP change how we experiment? I think you mentioned it briefly, but yeah, how could it change for teams?
Yeah, I think that's a good kind of bit of history right there. Is, before Kubernetes, every team had a different way of deploying containers, because Docker was around and people knew how to package a container, and there was a format around that, but to orchestrate it was another deal. And so I think, the beauty of Model Context Protocol, or MCP, is that before, when you had this approach of calling tools, it's definitely been around for a few years, that models could, like LLMs like ChatGPT or Gemini, could call GitHub to make a PR, or Slack to make that message. But the thing is, every team would have a different way of doing it. Rohan's team would have implemented perhaps their own API to make updates to that interact page. My team would have made our own custom integration to a different service, right? Model Context Protocol came around and said, hey, instead of building these custom and unique connectors from the LLM to the tool, you can standardize this in kind of a client-server approach, where the client's going to handle input and output from the model and the user. So, hey, I want you to make this request, and okay, I've processed that you want this to happen. And the server is the only thing that's going out and making the call. So typically, like a post call to a service, right? And so you can kind of see this here, is that we've got this unified API for different servers down here and the client that's up here. We call this the orchestration API because people typically think of Cursor or Claude Code or Claude Desktop as MCP clients, but there's actually a lot of other clients that you can use, maybe even in your application, using Llama Stack, which is this framework that we work here at Red Hat to give you MCP capabilities in your application if you're a Python or Java or JavaScript developer or mobile developer. So that's kind of the before and the after. That shows you what changed. It's not a huge revolutionary idea, but it's just a standard so that we don't reinvent the wheel a bunch of times.
No, it completely makes sense. I mean, especially the interconnectivity. What I wanted to, so I'm just looking a little back and forth. I see that you have some fans in the comment section. So definitely drop any questions you might have for Cedric and I. We can dive deeper. That's the aim of the show. And also don't forget to scan the QR code in the corner so you can do this interactive experience with us. So yeah, we talked about MCPs. If we can continue the demo, I think we're heading into Guardrails, if I'm not mistaken.
Yeah, but actually, I just saw there's some questions in the chat. So I see one of them is kind of talking about how why different models, or why what is the model play around. So the model here in the situation is kind of interoperable. So it could be a proprietary LLM like ChatGPT. It could be something that's open source like DeepSeek or Llama. The thing is to note here in this situation is, like, say if you, for example, go to Hugging Face, where we compress and quantize and benchmark models here on the Red Hat AI page, or you just go to the main page and you can see these models that are out here. Some of them can call tools and some of them cannot. So if you're using something like, I think, Llama 3.0, which isn't trained for tool calling or something previous like that, you're not going to get the right JSON output for an MCP client to make that request to a server. So there's specific models. So maybe you go to Olama's page here that are capable of using tools. So GPT's model from OpenAI, or Qwen, or Mistral's models, IBM's Granite 4, which are trained for tool calling capabilities. So MCP makes it so whatever model you're using, it's going to be standardized from the client to the server, so that you don't have to kind of worry about that abstraction breaking. You just have to have a model that's tool calling enabled and a server that has authentication to your services. And so it kind of makes it easy to say, hey, I was getting good results with Granite, but maybe I want to switch to another type of model, or vice versa, to get better or more accurate results with the tool calls. We'll come back over here. And yeah, let's talk about the next section. Concerning guardrails and concerning the enterprise use of agentic AI, I've seen a lot of hesitation about saying, or about letting MCP servers, and I guess just in general LLMs, connect to enterprise data sources, right? This is really, really important for 2026, especially right now, as we look to going beyond RAG and beyond chatbots to these type of production AI assistants that you see, for example, Amazon's Rufus shopping assistant that I used literally this morning. So you need a kind of a wide variety of capabilities that you kind of see going from Kubernetes, which is kind of, the vanilla type of orchestrator, to OpenShift, which is an enterprise ready container orchestrator, which includes, say, for example, RBAC and security policies, and a lot of other batteries included, as I like to say. And so that's what we're trying to do with MCP here with OpenShift AI. So this means trusted catalogs that we vet out with our partners. So you see here Dynatrace or GitHub, or as we showed earlier, the Kubernetes MCP server, so that if you want to integrate these into your application as a developer, as a team, you can easily vet and see what different capabilities there are that you can start using pretty much today. And I mean that because if you go over to the MCP servers for OpenShift AI, you can see that with our partners, we've got a lot of different servers that you can start using. For example, the AWS API to kind of make modifications to your infrastructure, Couchbase, Dynatrace, GitLab, Postgres. So there's a lot of capabilities and documentation that you can kind of start to see here. But I'll kind of come back here to why this is important. So the thing is, instead of just going ahead and giving trust to MCP servers and to your LLM, it's really important to do testing to see what is the expected output and how much can we trust these LLMs, as we're kind of still more in the early days of agentic AI adoption for the enterprise. So there's kind of a staging area with the OpenShift AI 3.x, or Red Hat AI now, as we call it, 3.x, that's coming out. And so you can test with different models that you can deploy from the AI Hub that have been vetted, as we talked about before on Hugging Face, with different MCP servers, combine them, use them individually, and then see what capabilities you're going to get out from agentic AI. And so this is this playground area to kind of vet things out, to do auditing, to do risk analysis before you actually deploy into production. And we think that's really important because, we've seen some cases already where, giving full access to an MCP server or agentic AI system could have, undesirable outcomes. And so we kind of need to treat agentic AI with this least risk possible type of approach, where we start out with the absolute minimum permissions and then go from there based on what we need, instead of going from read, write, access, and then going the other way. So that's a little bit about what's to come in Red Hat AI.
No, great. I mean, listen, if you're out there and you're still nervous to, start using this, don't be. I mean, we've resolved it for you. No, but definitely follow some of the resources Cedric has shared. I mean, like you mentioned about the guardrails and the governance and just our back and things like that. It's important to just play around with it.
Absolutely. Rohan, have you tried any agentic AI tools yourself?
Honestly, I think I only got to try the ones that you've presented in this demo, but at a high level. And so I know that your team dives deeper into it. You've done some presentations already, right? Like on your travels?
Yes, yeah. So the big thing is, I guess this Kubernetes MCP server that we've been kind of talking about, that we're really proud of, which has kind of been getting popular as of recently for Kubernetes and OpenShift. But there's also a RHEL Lightspeed MCP, and also Insights and Satellite servers that have been coming out. And so I highly recommend that people test these out, because it's really cool. Think about a system like Linux, right? Where you've got a lot of journal logs and system D logs of who's accessing what, permissions for each user, which typically you need to be pretty advanced, maybe RHEL certified, or have knowledge of how to interact with Linux to be able to pull that information and be able to translate that to someone else who isn't as technical, for example. And so tools like this, like the Linux MCP server, or RHEL, it's not RHEL, but it's
I think there's a
Satellite
couple,
or
right?
Insight.
We have so now Satellite is Red Hat Lightspeed, and so we have the Lightspeed MCP, which I'm
Mhm.
also going to drop a link in the chat. We have our Ansible one, which you mentioned earlier as well, right?
Yes.
So this shows it goes across, and beyond this demo. It's across our product portfolio.
Yes, exactly. So whether you're working on Linux, or, as we showed today, Kubernetes and OpenShift, or beyond with Ansible, and whatever your technology stack is, I think just take a look at what type of agentic AI capabilities there are out for you. You can use proprietary models like ChatGPT. You can use models running locally with OLAMA or VLLM on your own machine, even if you don't have the highest capability of GPUs yourself. I ran that demo actually on my own Mac using a local LLM. So definitely check it out. And I'll kind of wrap it up here. Red Hat's approach to MCP is fitting into Red Hat AI 3.x. And so with the registry and catalog, as we saw, there's a way to stage, just like we stage our applications, but stage MCP servers. But there's also lifecycle management. Right now, there's already lifecycle with models. So version 1, version 2, and signing those models to attest to their security. But there's also going to be that for MCP. And then an MCP gateway that we kind of talked about, that kind of combines a lot of these capabilities. And I'll just point you to kind of a last resource. If you go to redhat.com/AI/agentic AI, you can kind of get more information about our MCP servers, about different tasks. You can see another demo that we have, which is really cool, that uses a sales portal to kind of pull in different customer information, put that as a PDF, send that into Slack, which is really cool. So similar to what we did here today, but more for the enterprise. So it's pretty cool to see that. And get you started on your journey. But of course, this all ends up here at the interactive experiences. Thanks to you, Rohan, and your team for putting this together. helping people learn about open source technology.
I mean, great demo. One of the more active contributors, so awesome stuff. I mean, thanks for bringing it all together. So at the end of the day, just showing that it's where we started, where we've ended up, and how it all links, especially when it comes to the community, open source, but Red Hats and Red Hat products and Red Hat's how we're also developing. And so, like Cedric said, definitely check out the QR code in the corner and interact. I mean, essentially, it'll take you to interact.redhat.com. And any leaving notes, Cedric? I mean, imagine you are an enterprise. I know we're at time, but you are an enterprise and you're still nervous, but like you just want to take the first steps. What is a realistic first agent teams could build? I know you mentioned even with Slack and GitHub.
Yes.
Any ideas?
Yeah, you just reminded me of an article that we put out that got quite popular recently about kind of 3 MCP servers that was based off of this demo. So it tells you how MCP servers are put together, what you should know about MCP and safety. As I talked about at the beginning, or I guess a little bit earlier, we don't want to expose private data or allow for that to be communicated externally. So there's kind of the idea that you should use least permissions possible in any case that you're using MCP servers. But the Kubernetes one, I love. Context 7, if you are needing your LLM to always have up-to-date documentation on, say, the latest version of Java or JavaScript. GitHub is a really nice one because let's say that, as a developer, you're constantly, triaging PRs and going through issues and discussion boards. This makes it a lot easier to not have to go through the website, but to just send one command from your client of choice, which when we talk about clients, we talked about Claude Code, but there's the Agentic AI Foundation that was started recently. And this includes a lot of the open source contributors to the agentic space. Specifically, MCP is one of them. Agents.md, which is more about vibe coding and coding agents. But Goose is a really cool tool that I showed earlier as the client to make those requests. And Goose is this kind of CLI that allows you to make code edits, use MCP servers, and test out any LLMs that are running locally or connect to those that are remotely. So you've got the MCP client here that can connect to the MCP servers just like this and use local LLMs. So the opportunities are here. It's free, it's open source, and I'd just say get started today.
Yeah. So if you were new to this, you just left with a bunch of resources. So just get started, like Cedric said. And I mean, thanks for joining us today on this demo deep dive. This is our first episode of the season, new year. So looking forward to having this regular cadence. We are on every 2 weeks. So if you have any topics as well, feel free to drop it in the YouTube channel's chats. And we'll be back in 2 weeks with Cedric and talking further about we have, I mean, just the various topics we have at Red Hat to cover: virtualization, AI, deep dive into RHEL 10, OpenShift 4.20 one that's coming out. So yeah, thank you everyone.
Thanks, Rohan. Bye, guys.